Hello friends, hello friends and my dear students. I welcome you all to my channel. If you are new to my channel or not yet subscribed, I will highly request and suggest that you support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. In this video, I will start the next chapter on ratio and proportion. So this is part 1 of the series of videos on ratio and proportion. So this video is part of the playlist CBSE Mathematics Class 7 following the textbook of author R.S. Aggarwal. In this video, I will discuss the topics ratio and its terms, simplest form of a ratio, properties of a ratio, comparison of ratios, and I will only discuss the concepts of all these topics. I will not do problem solving from the exercise. While discussing the concept, I might discuss about I might give examples of small problems, but those will be very conceptual, not a real problem from any exercise or any textbook. So in the next part 2 of the problem of the video, I will solve problems from exercise 8a related to these topics. So let's get started with this today's video. Okay, so as usual, I have my notes on the left hand side, and on the right hand side I will discuss the concepts. So what is you might have already studied ratio and proportion in class 6. I am not sure of that, but let's understand from basics what is the ratio. In this video we will only talk about ratio but not proportion. We will talk only about a ratio. So let's talk about the ratio and its terms. So the textbook says that a ratio A is to B is the fraction A by B written as A colon B. So when we talk, so a ratio, this thing A is to B, this is a statement in words defining or representing the ratio, a ratio between A and B, and A and B are some quantities. A and B are some quantities. Now mathematically the ratio, the value, the ratio is equal to A by B, and it's a fraction. It should be a fraction, and the ratio A is to B. This thing is in words. Words meaning the ratio of A and B. Now basically a ratio A is to B, okay, and this is mathematically its value is A by B, the fraction A by B, and mathematically the mathematical notation of the ratio A is to B is A colon B. This symbol is colon, A colon B. Now this is the notation. This is the notation. This thing is the value, comparison value. We can say that comparison value, and this is in words. So basically when we say a ratio actually gives a measure of comparison of two similar quantity having same units. Now please try to understand very clearly that the ratio A is to B or A by B is giving a measure of the comparison of two quantities. Let's say they are A and B. If the quantities are A and B, then A and B are some quantities, meaning they will be some numbers. They could be some numbers. It could be fractions, decimals, or they could be whole numbers. So they actually represent some quantity of some kind, and they must have similar units. That is, if A is an age in years, then B should also be age in years. If A is a quantity in length in centimeter, then B should also be a quantity in length, quantity of length in centimeters. So they must be of similar kind, and the units must be same. Now when we say they usually say that A and B are in ratio A is to B. This nothing means, this actually means that A by B equals small a by B. Okay. Now in this ratio, in this term A colon B or A is to B, the first term A is known as the antecedent or the first term of the ratio A is to B. You can follow the notes while I speak. The A is known as the first term. A means this one. This is the first term known as the antecedent, first term of the ratio A is to B, or known as antecedent, and B is the second term of the ratio A is to B, and is also known as consequent. Now you see some examples are given in the notes. The ratio, so we say that the ratio, so what so if two quantities are given, if the values of A and B are given, then we can say that A by B, whatever the value is the ratio of the quantity A and B. So some examples are given. The first example says in the notes, the ratio of 50 kg to 30 kg is 50 by 30, and we can since it's a fraction, we can reduce the fraction further, and we can say it equals to 5 by 3. Now, and eventually it is 5:3. Now it will also be right if we say that the ratio is 50:30. That is also right. Why 5:3 and 50:3 both are same correct, we will discuss that a little later. So another two examples of ratios are, let's say the ratio of two and a mixed fractions, 2 and 1/3 and 3 and 2/3. The ratio will be, you just divide the two quantities and then you can further reduce it, and it will be eventually a fraction. So the quantity, any two quantities A and B, whatever their value is, you will when you do A by B, that eventually will be a fraction, and if you reduce that fraction to its simplest form, then the numerator is if you reduce that to its simplest form, then the numerator is to the numerator colon denominator is actually the ratio. Okay. Now something to note, that ratio can be between two or more similar quantities. Now so far we have discussed the ratio between two quantities A and B. It can be ratio between three or more quantities like ABC, where ABC are quantities of same kind and same unit, or it could be a ratio of four quantities A, B, C, D. So in the example you can see rupees 5 and rupees 10 and rupees 20, these are three quantities in rupees, are in the ratio 5:10:20. Now 5:10:20 can further be reduced to 1:2:4. This ratio 5:10:20 is also equals to 1:2:4. We will discuss this a little later. Why we can reduce this ratio 5:10:20 as 1:2:4. Okay. Now always remember that the ratio, the quantity whose ratio we find, they should always be of same kind and same unit. So if you see the example number 2, rupees 2 and 50 paisa and 75 paisa are in the ratio 2:100. Why? The rupees 2 has been converted into paisa, unit paisa. So we have to convert all the quantities into paisa. Since the second and the third quantities are given in paisa, so we have to convert the first quantity, that is rupees 2, into paisa. So we are so the ratio will be 2:100 is to 50 into 75 is to 75, and you can further reduce it to a smaller ratio. I mean the terms will be smaller. Similarly, you can see the example 3, 25 ml, 70 ml and 2 liters are in the ratio 25 is to 75 is to 2000. Why 2000? Because we have to convert the 2 liter quantity into ml, and we know that 1 liter is 1000 ml, so 2 liters is 2000 ml. Okay, so now we have understood what a ratio between two quantities A and B is. Now so the ratio could be between two quantities or two or more quantities, 3 quantities, 4 quantities. So for two quantities, let's say for two quantities, if we consider two quantities, we say that A and B are in ratio. If we say small a is to B, we can also say that A, B, C, 3 quantities are in ratio small a is to B. This is the way we write. Similarly, it can be A, comma, B, comma, C, comma, D. 4 quantities are in ratio A is to B is to C is to D, where A, B, C, D are some numbers. Now, at this point, you must understand one thing very, very carefully. If this thing A and B are in the ratio A is to B, so you from this you know that the value of A divided by the value of B will be equals to A by B. Now in problems you will be given only this. If you are given only this, that the ratio of A and B is small a by B, from only the ratio you can never say what is the actual value of A and B. It is not possible. To actually find the actual values of A and B, some other information must be given. While solving a problem, we will see why is that so. So just if you are given the ratio between two quantities A and B, from just the ratio you will never be able to say what is the actual value of the two quantities. This thing you should keep in mind. Okay, now also note that there is no ratio between quantities of different units. We never say the ratio of two different units. Like example, there is no ratio between 2 kg and rupees 50. We never talk about a ratio between quantity whose unit is kg and another quantity whose unit is rupees. Or we never say the ratio between 5 meter and 60 ml. ml is a unit of volume and meter is a unit of length. So this we never say. Okay, so now properties of ratio A is to B. If you are given a ratio A is to B, what are the properties? Now A is to B, we know that mathematically its value is A by B, the fraction A by B. Now for a fraction, we know that if you multiply for a fraction A by B, you know from the chapter fractions that we can multiply any non-zero number to both the numerator and the denominator, the fraction remains the same. So for a number m which is not equals to 0, non-zero number m, we can multiply A and B with m, and we can say that A by B equals to A into m divided by B into m, and so it becomes AM by BM, and so we can say that the ratio is MA is to MB. Now, so we can do this. So for example, if you see the 2 is to 3, the ratio 2 is to 3 is nothing but 2 by 3, and we can always multiply some non-zero number. So we are multiplying both the numerator and the denominator by 3, we get 6 by 9. So we can say that the ratio 2 is to 3 is equivalent to or equal to the ratio 6 is to 9. Similarly, the second example, the ratio 9 is to 6 is nothing but the fraction 9 by 6, and we can always divide. Okay, so the property 2 was, if the ratio for a ratio A is to B, we can divide both the numerator and the denominator by a non-zero quantity, let's say m, and the ratio remains the same. So the ratio A is to B can be is equivalent to or is equal to the ratio A by m is to B by m, where m is some non-zero quantity. So in the example 9 is to 6, ratio 9 is to 6 equals to 9 by 6, and if we divide this fraction by both the numerator and the denominator of this fraction 9 by 6 by 3, we get 3 by 2. So we can say, which is a ratio 3:2. So we can say that the ratio 9:6 is equal to ratio 3:2. So saying that a ratio 3:2 and ratio 9:6, they are same ratio. Okay, now ratio A:B in simplest form. When do we say that a given ratio is in simplest form? So a ratio is given A:B. This is nothing but mathematically its value is A by B. We say that the ratio A:B or A by B is in simplest form if the fraction, basically if the fraction A by B is in the simplest form, or the HCF, we say HCF simplest form, this fraction A by B is in simplest form if the HCF of A and B is 1. That is, A and B has no common divisor other than 1. So the ratio 4:6 is not in the simplest form, because the HCF not in simplest form, Why? Because HCF of 4 and 6 not equals to 1. HCF of 4 and 6 is 2, so which is not equals to 1. So these ratio 4:2, 4:6 is not in simplest form. Now, but the ratio 2:3 is in simplest form, as HCF of 2 and 3 is equals to 1. So whenever, usually in a problem, a ratio is given in simplest form, usually, but it is not mandatory, but usually in all problems the ratio will be given in simplest form. Now the second concept is that okay, so when two similar quantity A and B is said to be in the ratio A:B, it means that A by B, capital A by capital B equals A by small b. This we have already discussed. Now how do we convert a given ratio in simplest form if it is not already in the simplest form? So let's say the ratio, please follow the notes. If the ratio, we are given a ratio A:B and which is not in the simplest form, then to convert the ratio A:B, we just divide A and B by the HCF of A and B. Since A and B, A:B is not in simplest form, definitely the HCF of A and B will not be 1. So we will divide both the numerator and the denominator of the fraction A by B by HCF of A and B. So as example, you see the ratio 2:5, 2.5 is to 10. 2.5 we are given the ratio 2.5 is to 10 is nothing but 2.5 by 10. Now this is equals to 2.5 is 25 by 10 divided by 10. So we get 25 by 100, which is 25 by 100. Now okay, so let me explain. Now if you are given a ratio 2.5 is to 10, this ratio is given. Now we know that this is nothing but in the fraction form, this is 2.5 by 10. Now 2.5 is nothing but 2.5 by 10, and we have by 10. This is after simplification, 25, 2.5 is 25 by 10, 25 by 10 by 10. So this is after simplification 25 by 100. Now we can say that the ratio is 25 is to 100. We can always say that this is correct. So the ratio 2.5 is to 10 is equal to the ratio 25 is to 100. We can always say that. But this is 25 is to 100 is not in simplest form. Because the HCF of 25 and 100 is 25. So if we divide the 25 by 100, if we divide both the numerator and the denominator by the HCF of 25 by 100, which is 25, we get 1 by 4, which is equal to 1:4, and this is in simplest form, because there is no common divisor of between 1 and 4. Okay. Now there is a concept of comparison of two ratios. If two ratios are given, how do we compare them? So two ratios are given, A is to B and let's say C is to D. We compare them just like we compare fractions. So we know that this ratio is nothing but A by B, and this C is to D is nothing but the fraction C by D. Now we will compare these two. We will compare A by B, the fraction A by B, and the C by D, and whichever is greater, if A by B is greater than C by D, then we say that the ratio A is to B is greater than C by D, and if the fraction A by B is less than the fraction C by D, we say that the ratio A is to B is less than ratio C is to D, and if A by B is equal to C by D, we say that the ratio A is to B is equal to the ratio C is to D. So this is how we compare two given ratios. So from this comparison of two ratios, we can solve problem of arranging a given list of ratios in descending or ascending order. Okay. Now, if ratio of A and B and C are given, then okay, let's say we are there are three quantities A, B and C. There are three quantities A, B and C, and they are of same kind and same unit, and it is given that the ratio of A is to B, the ratio of A is to B, it's not proper to write, okay, it is okay to write A is to B is given to be small a and small b, where small a and small b are some fixed constant numbers, values, but A, B, C quantities are unknown. Let's say it is given that A is to B, small a is to B, and it is given that B is to C equals B into B is to C. Now you see that in the ratio A is to B, we have the term B, second term is small b, and also in the ratio B is to C, the first term is B. So the term with respect to the quantity B is same, B. From here we can say that all the three quantities A, B and C are in the ratio A is to B is to C. So reversely, if you are given this, from A is to B equals to, from given facts, A is to B, capital A is to capital B equals to small a is to small b, and capital B is to capital C equals to small b into small b is to small c, we can say that the ratio of capital A, capital B, capital C equals to small a is to small b is to C. Now from the fact, if this is given that the three quantities A, B, C are in the ratio small a is to B, small b is to small c, from here we can say that A by B equals small a by small b, and capital B by C equals small b by small c. We can say this. Okay. So this thing, some concepts, I am only discussing concepts. It will be nice if you take notes of what I am saying and take notes in your notebook regarding all the concepts that I am discussing. Now these are all concepts behind that will help you solve problems. Now typical problems or typical problem is that how do you divide a quantity A into two parts in the ratio A is to B. So there is a quantity A given, that this quantity could be any value, any number of some kind, of some unit. It could be age, it could be length, it could be weight, it could be whatever. So it is asked that divide divide A into two parts in ratio. The ratio of the two parts is given to be A is to B. So it is asking that a quantity A has to be divided in two parts, so that the first part is to the second part, first part is to second part, is A is to B. A is to B will be given. Now you will be asked to find the first part, the quantity of the first part and the quantity of the second part. So if we in the notes, so the first part, the actual quantity, the actual quantity of the first part will be the first term in the ratio, with A divided by the sum of the terms A plus B, and this whole multiplied with the total quantity, that is A. So you are dividing a quantity A into two parts, and it is said that the two parts will be in the ratio A is to B. So how to find the two parts, the actual value or the quantity of the two parts? So the formula, the straightaway formula is, the first part will be the first term in the ratio divided by the sum of the terms multiplied by the total quantity. Similarly, second part will be equals to the second term in the ratio divided by the sum of the terms in the ratio multiplied by the total quantity, second part. This will also work, the same logic or formula will work for if you have to divide the quantity A into three parts where the ratio of three parts are given. So in the notes you see that dividing quantity A into three parts in the ratio A is to B is to C. This ratio A is to B is to C is the ratio of the three parts that you have to divide from the total quantity A. So that means if the ratio of the three parts is given as A is to B is to C, it means that the first part divided by second part will be A by B, and the second part divided by third part will be B by C. Now the actual quantity, the actual value of the first part will be the first term divided by the sum of the terms multiplied by the total quantity. Similarly, the second part, the actual quantity or the value of the second part will be the second term divided by the sum of the terms in the ratio multiplied by the total quantity. Similarly, the third part will be the third term in the ratio divided by the sum of the terms in the ratio multiplied by the total quantity A. So this was all about the concepts of a ratio. More or less, I have covered all the concepts that will be required to solve problems. So in the next video, I will solve problems from exercise 8A. I will try to solve all the problems because I think that solving all the problems will give you a better idea of how to approach a problem and how the concept of ratio and all its properties has to be applied to solve a problem. Now I know that this video was more of theoretical, but I hope I gave you clarity of concepts on the ratio of two terms or the ratio of three or more terms, and about the ratio of same quantity having the same unit. When we will solve problems, when we will apply the concept, it will be more clear. Now, okay, so after now that I have discussed the basic concepts of ratios, properties, and I would like to ask you a question. If you are able to, I do not have a proper answer to this question, but this question came in my mind, and I thought to ask you. If you can answer this question in the comment section, I will be very pleased. So the question is what is the ratio of two temperatures minus 5 degrees centigrade and 9 degree centigrade. Now these two quantities are same quantity, they are both temperatures and the units are same, degree Celsius. So one temperature is measured as minus 5 degrees centigrade and another temperature is measured as 9 degrees centigrade. What will be the ratio of these two temperatures? Please let me know in the comment section. I will be pleased to have your answers. And thanks for watching. I hope this video was beneficial in understanding the concepts, theoretical concepts of about ratio, even though we did not solve problems. I know that without solving problems, anything in mathematics is incomplete. But in the next video, I will solve all the problems of exercise 8A that will, I hope that will clarify any doubts that you might have after seeing this video regarding the concepts of the ratio and its properties. So please stay tuned for the next video where I will solve all the problems of exercise 8A from the textbook of author R.S. Aggarwal. Thanks for watching, and once again, if you are watching my videos regularly and not yet subscribed, I will highly request and suggest that you support me, subscribe to my channel, share my videos with your friends, like them, and also please do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.